Hello, this is the second video to logical reasoning and counterexamples. So let's look at some definitions for counterexamples. So a counterexample is an example that proves that a statement is false. So for example, let's say that we have this conditional statement. If x plus y is greater than x times y, then x must be greater than y. However, let's suppose that x is equal to 1 and y is equal to 1. This means that x plus y is equal to 2 and x times y is equal to 1. So as you may see here, 2 is greater than 1, which makes the hypothesis true. And as you saw in the previous video, if the hypothesis is true, then the conclusion must be true. However, in this case, 1 is not greater than 1. If it had said greater than or equal, then it would have been true, but it isn't. So, the conclusion is false. And this cannot be true. This if and then statement, this conditional statement, cannot be correct if the hypothesis is true and the conclusion is false. That is impossible. This means that this whole statement is invalid. Now we will see some examples and exercises for identifying the hypothesis and conclusion of some statements. So for example, we have Kellen eats hot dogs at baseball games. So what is our hypothesis and what is our conclusion? There are a couple of ways of doing this. So let's say that the hypothesis is true. We need to make sure that the conclusion will be true. So if we think that maybe the Kellen eats dogs is the hypothesis, well, let's say, well, Kellen is eating a hot dog, I'm sorry. So this means that Kellen is in a baseball game, but not necessarily. She could be eating a hot dog in her house. So this is kind of telling you that no, this could not be the hypothesis. However, if we think that going to a baseball game is the hypothesis and eating hot dog is the conclusion, let's make sure that this is right. So if Kellen is in a baseball game, that's the hypothesis, then for sure she's eating hot dogs because the statement tells you that. So if the hypothesis is true, the conclusion is true, which is what we want to happen. So based on that, looking at what the two hypotheses could be and which one is the correct one, we could identify that going to a baseball game is the hypothesis and eating hot dog is the conclusion. Now let's look at another statement. For any square that has an area of 16 square inches, each side has length of 4 inches. So, here, what do you think could be the hypothesis? Well, let's look at the two possible answers. We could either have for any square that has an area of 16 square inches. So the square with an area of 16 inches. And the other possible is each side has a length of 4. So here, what tells you what is the answer is that we have any right here. This is kind of like an always. So it's telling you if the following statement is true, then the second statement will always be true, which is what you want to have for a hypothesis and a conclusion. So here, since we have always, or in this case any, we can be sure that the first statement will be our hypothesis, since every time the first statement is true, we are guaranteed that the second statement is true as well, which is what we want of a hypothesis and conclusion. So this is our hypothesis and this is our conclusion.